Good afternoon. It's a real pleasure to be here with you and quite a privilege really for me to be able to present to you the story this afternoon of the innovation, as we put it here, making the invisible visible, UViRCO, an innovation success story. We heard this morning from the chairman of the CSIR board around, he was asking questions about how intentional is CSIR in terms of innovation and actually creating jobs in high-tech startups. And so hopefully you'll get an example of something where we've actually done that. I think as SET professionals, science, engineering, technology professionals, we are very much attuned to the fact we need to be making impact out there. And so to see it all come together and to realize what was involved in that story is quite something. And this is just one of obviously many technologies underway at CSIR. So I'd like to share that story with you. I'm going to do it through these bullet points. So just quickly, I'm going to give you one slide on what we claim the innovation is. I could go into lots of technical detail, confuse everybody equally, and then tell you what it's about, but I kind of figure I should do it the other way around today. We'll then connect the dots from where we started to where we finished in terms of the Eskom CSIR story. We'll talk a little bit about UViRCO, how they were set up, how they're currently structured, how they operate, what some of the products are, and give you an idea of how the innovation that they have actually driven within their organization has continued over time. I'd like to give you a couple of slides which is really self-interest, telling you where did this come from within the CSIR. I'd like you to understand a little bit about the DNA of the group that actually created these technologies and how they go about it. I'd like to talk about some key ingredients in making innovation happen, and these are beyond the hard policies and all those kind of good words you hear. Most of these are the soft issues other than funding that were actually important for us so that we could actually make this happen. Without these, we would never have got where we are today. And then just a couple of slides to wind up on the future. So if I can just start off in terms of the innovation itself, as I said, I'd like to give you just one slide on it, which really, and this is the simplest way to put the message across, is to say, how did we go from 1991, where Eskom made a phone call and asked whether we could help out with inspection of insulator technologies, through to a position a number of years later, we spun UViRCO out in 2008, where we've got a brand new South African brand and company on the world market. You can see the kind of products that are coming out of the organization. You'll see just now how those evolved from the early products we made. And just the last 4 years, how the company has turned over in excess of 100 million rand sales, 38% sales growth a year, and in excess of half of the world market in their areas. Now, to have a problem and to come up with creative solutions and to eventually get that to market and commercialize it, that's innovation at its best. And that's really what we've done. And what I'll tell you today is, I suppose I'll fill in the blanks over here, the dots. How did we actually get from one through to the other? Okay, so let's just talk a little bit about it. By way of background, I assume you all know what insulators are when we say these are sitting on power pylons and substations around the country. They're not just electrical in terms of function, they're also mechanical. So these actually support the weight of those cables that are sitting up, they're the conductors. And so they do degrade over time from environmental reasons, but also they've got high voltages and currents and so on. They do degrade over time and they need replacing. And of course, they're actually sitting quite high up. So they're difficult to necessarily get to. They've got very high voltage, a lot of danger involved there. And in the early 90s, when the story began, Eskom were starting to introduce the new polymer-based insulators. Now, how do you know when those are failing in the field? The effect of a failure is you lose electricity supply, which at one point you had to explain to people the implications. But with load shedding, I don't think I need to explain to anybody the implications. Okay, so this is to avoid it and be proactive about it. And the question really from Eskom was whether you could actually develop some inspection technologies, initially that could be used in a laboratory environment, but eventually we want these out in the real world and to be used and make an impact in terms of Eskom's business. The insulators themselves, when they start to degrade, you may have been out in the veldt at some point beneath one of these and you've heard a crackling noise, which is when they're starting to degrade, you'll hear acoustics, you'll hear sound energy coming out. But they also emit favorably corona, which is invisible to the naked eye. That's the ultraviolet that's coming out. But they do a number of other things as well. That corona also creates things like nitric acid in the vicinity of that insulator, which helps to degrade it even quicker. And you really don't need these things failing and going down. But the fact that there was UV coming out meant that we had some angle on how we might actually be able to detect that there was a corona present, and the corona is an indication in turn that there's a problem with the insulator that's developing. So the technical challenge we had was actually, can we image the low intensity corona UV that's coming off these insulators? And it really is low intensity. It can literally be on the order of a few photons per second sometimes that are coming off. And can we actually do that? And the answer originally we decided was yes, we could do it. And that's the title of the talk, obviously making the invisible visible. If you look at the physics of the situation, how do you detect that corona? You need to look at the spectral radiance curves here. So if we just take the solar energy that's coming out, the energy that's coming out of the sun, and we plot it against the electromagnetic spectrum, just in nanometers here, you're all familiar with the rainbow, just red through to violet, the visible wavelengths, but we've got infrared occurring on the top end here and ultraviolet down there. I've plotted the corona signal a 10 to the 4 factor on here, otherwise you wouldn't see it. But the corona actually gives you some characteristic peaks right down here. And we decided at the time that if we can detect these two main peaks, 340, 360 nanometers, then we could probably pick up the detection of a defect actually in that insulator. So the decision was, yes, we'd actually like to go ahead, work at those two areas, and that really started a journey which spanned basically 2 decades before we managed to get the innovation complete and get it out there. If you fast forward just 2 years, the team was, I think, quite dynamic to go from. I think of it in terms of you're sitting with that phone call. I don't know how many CSIR people are here who you take a phone call from somebody that says, can you do something about the following? And you kind of listen carefully, and eventually you say, yes, we'd like to get involved. But then within 2 years to produce your first working product that came out of the thing. And that we called it the CorraCam at the time, and that actual brand name has survived to this day. So a corona detection camera, CorraCam. In '93, we put out the first one, which was the CorraCam 1. This was actually only for use at nighttime. If you think of that huge solar coming in at 10 to the 4 times the level of your corona, you don't really want to be doing it in daytime. You won't pick up those signals. I was looking at a book the other day that my kids had found in the late 80s, early 90s with the Star Wars franchise, and this looks like one of the devices that came out of that movie. It's got the same kind of era styling and so on, if you're with me. But we actually restyled it over time, and funnily enough, even though it produced back in '93, it kept going up to 2010. UViRCO still made some of these up to 2010. Now, in the early days, it was a case of satisfying the requirements from ESCOM, but we realized through the networking internationally that other utilities and research labs on these insulators were also looking for tools. These tools didn't exist, and there wasn't really a market to sell them internationally at that point. So it's not a bit like Apple coming in late and selling cell phones when the market's been there. We're actually the guys coming in right in the early, like the Nokias, and developing the technology from scratch. And so a number of power utilities also started to buy these things. So we made a few, and of course you learn a lot by actually making them, and you can start improving the reliability. A couple of years later, we'd actually moved on. The requirement then was moving more to, can you increase the resolution of this? So you might think this is a modern phenomenon with our cell phones and tablet PCs. We always want more and more resolution. Even back then, it was realized that resolutions had to increase. So you can see an example here of the corona discharge taking place on an insulator. And so, in essence, by making the invisible visible, you can start to see where you're having defects occurring and where the corona is coming off and how much is coming off, and you can start to see some of these patterns that are created. And even this one, the CorraCam 3 we called it, was sold through until 2009. Very small thing, used in nighttime only, so very much, you can use it in the lab obviously, but you could also go outside and use it at nighttime. But at some point, these engineers who are in the field, and if you're in the Karoo in the middle of the night and kind of it's winter, you don't really want to be out there inspecting pylons. So there's always pressure to try to get to a daytime system. And if you go back to this problem, obviously you've got to find some way of making your sensor not pick up all the UV from here, but in some cases you'll be picking up some of the visible energy that's coming through as well. So we tried filter technologies, and we tried pinching off some of the extra signal coming in here, and we tried shutter synchronization and a number of other techniques in that 340, 360 region, but never really got there until the technology moved on to the point where we could actually finally start to get below where the solar UV cuts out, which is around the 300 nanometer level. Okay, and so when we started moving there, we call this the solar blind region down here. This is mostly absorbed by the atmosphere. So if this made it to Earth, we'd all have really good suntans and wouldn't be alive, to be honest. The UVC is taken up by the upper atmosphere, mostly. This is where we get most of our suntan from, is actually from the, let me just move on, sorry there. It's from the UVA and B, okay, but the filter technology in terms of taking out the extra wavelengths eventually allowed us to work below the 300 meters, in fact nanometers, and we got down to 200 nanometer 280 nanometers. And this resulted in this looking device, which we called the Coracam 4 and the 4 Plus. And these ones are actually able to operate for the first time ever. It was a world first achievement for the team in daylight, and you could go out and inspect. And talking to somebody from ESCOM the other day, I understand they still have one of these. So the team that originally made it, Roel and Dirk and the guys, they've still got it. They just need new batteries. Okay, if you could put new batteries through. But the camera apparently still works. So all congrats there. But this actually opened up the potential for the commercial side of the industry now. Because if you can do something in daytime, the interest levels just grew around the world. Of course, initially we dealt directly with the overseas companies, but you eventually realized that you actually need somebody in between to deal with all this. And so we started a network of international agents who started to represent us and then started to propose these into the different utilities and universities. And that led by the mid-2000s to us having realized there was a commercial potential. We worked again with ESCOM funding as well as CSIR funding to try to produce something which was a lot more commercial looking and feeling and in terms of its performance. And this is what we call the Coracam 504. We even did software for it, and we could start now capturing the images. The electronics in here was more powerful. You started having memory cards. You could store things, transfer them to the computer, and so on. There was also techniques on the image processing which allowed it to indicate which were the stronger UV signals that were coming through. Because remember, these might just be a few photons per second sometimes. And when you're looking up into the sky, you've got the solar UV coming in. So you've got to be very careful that you've actually pinched off all that at the same time, because it's coming in the lens. Okay, by 2006, we obviously realized we needed to start commercializing. And that, fortunately, was when the CSIR rolled out much more extensive technology transfer, intellectual property, and contracting capacity within the organization with our Beyond 60 process. And so we had capacity then to start moving it forward. Okay, so the engineers had done their job. We now needed to get this out. Considered a number of different business models, and eventually we settled on a spin-out model in which we took 6 of our staff members and politely asked them to leave and set up a company. And really hats off to those people who did it, because I think you get in a comfort zone sometimes in where you're working and what you're used to doing. And what happened here was 6 people believed enough in what they were doing and that there was a market for this and they could grow it and they could turn this into a business. And so eventually 6 people went out, which means one day you're the research group leader, the next day you're the CEO, or you were the project leader, now you're the chief technology officer, and so on. And so these people had to go out and they had to reinvent themselves and actually get this company going. And so UViRCO was established back in 2008 eventually. And they were licensed for those cameras, the Coracams 1, 3, and 504. And by the time they had been set up with manufacturing, we'd also completed the next camera in the lineup, which was what we called the Multicam, which is multispectral imaging. Again, a world first in terms of 3-in-1 wavelength band, so visible as well as ultraviolet as well as infrared, all within the same camera system. And this was eventually licensed through as well. And we got some famous people interested in trying it out. You can see our ex-president Thabo Mbeki here with our late colleague Katiwe Kumalo, learning all about the Coracam series of cameras. And so that was a visit to the CSIR at the time we were commercializing. You'll see an example here of some of the images you get out of the first multicam. So you'd have a visible image of a power pylon with an insulator and the connections and so on. And you could overlay an infrared image, but you could also see the UV there as well. And by swapping between the images, storing things, getting them offline and stuff, you've actually starting to get to a really quite commercial product there. And that really is where the story diverts out of the CSIR and we move on to UViRCO and their era. And this was all done with a developing market, and it was able to mature within the organization before we actually took it outside. So if we look at UViRCO themselves, as I said, it was established 2008. They moved not too far away at Persicourt Techno Park, which is just opposite the CSIR there. We can remember having discussions that they weren't allowed to come into CSIR in those days because they needed to start afresh and see themselves as a new entity. So part of that was actually taking them out to a different location. We quite often talk within the CSIR of licensing technologies onto a company and the people stay. But if you go to the MITs of the world, you often see the person who's finished that technology with a PhD goes outside and starts the company. And that really is the principle here, that we took the champions, the people that believed in it, and they took the technology outside and set it up. So they're up and running, they believed in it, and they were able to get this going. So UViRCO was licensed to manufacture those Coracam and Multicam products, but also to do the marketing, sales, distribution, and then to start, once they were set up, their own ongoing product and technology updates. And I'll show you some of those now. And I really do feel that they benefited from those years of incubation. I'm not sure we realized what quite we were incubating at the time and the potential that there was there. But the market had to be created and warmed up, and then as the product matured and became manufacturable, so the commercialization process happened. In terms of UViRCO and how they operate, there is obviously UViRCO itself as a company set up for development, production, and the maintenance and support of the cameras. And what they do, they have that international set of agents, the worldwide distribution network, currently 32 agents serving 40 countries, that actually put in tender bids in their different countries in order to try and win the business here against other competition. And then they in turn pass the camera systems onto the market. If there are issues with the cameras or direct questions, then there obviously are connections between UViRCO and those market segments. The CSIR has maintained a research and development relationship with UViRCO all these years, and some of the CSIR new ideas and creative stuff is actually coming through into UViRCO. Funding has flowed into this whole area partly from ESCOM. The CSIR has sponsored, ESCOM has sponsored over the years. We're very grateful for all that support. But more recently, we've got some of the government agencies coming on. So the SPY program has now come on, and UViRCO has got its first SPY project. I'll show you the product just now that's being developed. And TIA this year joined the party. They are now sponsoring, as of this financial year, the development of a flagship product, the next generation of product that'll come out in 2 years' time, which will be a joint product between UViRCO and the CSIR. But of course, once you've got this in place, you've now got feedback mechanisms that are coming through that help you improve the product, but also look for brand new technologies, new product ideas, and so on that could be coming out. And so that's how they operate. As I said, next slide, not this one. Okay, these are the products. I mentioned just now about innovation and how UViRCO continued the innovation once they got it outside and listening to the market and the market needs. So these are the nighttime product range, okay, and I showed you just now the early Coricam 1s and the Coricam 3s, and those eventually merged, and by 2013 a very much newer looking product, definitely not Star Wars at all, with new display technologies here. And much more under the bonnet than we've ever had before. And you even get connectivities and the Ethernet ports and all these kind of things coming on now. And so that's how the nighttime product range has actually developed. So there's still a need for that. The daytime range went from the 4 Plus that we showed you over here through to the 2005 version, which was the 504. And now we have the 6D, which is back in 2011 that came out, which is selling very well. All of these cameras are actually on the UViRCO stand as part of the exhibition if you want to go along and have a look at them. And so you can see some of the images are starting to come out. We've got zoom capabilities in here now and much improved ways of just interfacing with the devices and running them. But also a common look and feel is starting to come out in those final products. The multispectral imager went through this set of stages, and just 2 months ago the Coricam 8 was released. Now this is the first time that the infrared channel is starting to bring in some measures of radiometric, but on that radiometry on the thermal channel. And so this was released just 2 months ago, and that's also over there on the exhibition stand. And the project that TIA is funding at the moment is to take these systems and make them fully radiometric. So the radiometric in the IR, but as well as the UV, which hasn't been done before. And that is something that we're trying to push the boundaries internationally, because if you can quantify how much UV is coming off, then you can start saying something about how severe a defect is, and you can plug that into your maintenance programs and so on. Okay. These are some of the other products. Once you've got the initial ones going, you start to diversify a little bit. One over here that's interesting is the day-night system. So this actually gives you the benefits of both worlds. It's set up in such a way that you can take advantage of that. The SPY project is the Vehicle Mounted Inspection System, VMI. So you can imagine this on a vehicle now, fully remote controlled, that you can actually spin it around and you can drive down your power line and start getting images of these insulators. And just from CSIR side, we're back at the proposal writing stage here now to get funding. In the same industry, the electrical transmission and distribution industry, we have the electrical switchgear that's used to switch power between circuits on and off and so on. Those are all insulated with sulfur hexafluoride gas. And this gas cam, as we're calling it at the moment, has the ability to go into a facility and be able to image and pick up exactly where the leaks are. And the first version is using a laser backscattering technology. We've got a second iteration we're now proposing to take forward and have another technology that can be put through to UViRCO. These are some of the ESCOM helicopters here. So these cameras get fitted into gimbal systems and fly around to inspect pylons. I've seen lovely footage of it going through the Swiss Alps, inspecting the power pylons and stuff. And we've worked with ESCOM as well on unmanned aerial vehicles, so we could actually have something a lot smaller, a lot lower cost to run that could be used in the field to do the measurements. This is an example of some of the clients that UViRCO has got. So you'll see some rather large names here. If you've got a client like NASA, the Jet Propulsion Labs, GE Global Research, ABB. We've got the US Navy, I think, as well. They're not listed there at the moment, but there's a number of really big clients. So the business is almost entirely an export-driven one at this point in time. And yeah, 32 distributors in greater than 40 countries at this point in time. In the past 4 years, 116 million turnover, growing at 38% in a year. And why it's selling really is they've created a very strong brand out in the market. They are very good at listening to what the market wants, attending the exhibitions and conferences and so on, and engaging with the agents in the different territories. But the products are of good quality. If you have a very low return rate, you know you're producing things of good quality. And some of these are operating in Siberias and places which are seriously cold. So you really have to make sure you get the product quality right. But they've also been very focused on satisfying the customer needs. So whatever you get from your existing or emerging markets, trying to build that in as quickly as you can, cut down the innovation cycle and get them out there. But give great customer support so they come back time and again. And that really explains how they've managed to grow the business, because in the meantime, competition is bound to appear and has appeared. So you've got to stay ahead, and sometimes these are the things that differentiate you out there. Okay, so that's UViRCO. In terms of where it happened at the CSIR, when the chairman this morning was talking about how intentional innovation needs to be if you want to make it happen, not just do research for the sake of it, but get it out there. That's a flavor that, having been at the CSR for a number of years, I see increasingly coming in, that awareness that we need to get technologies out there. And so the group we've got, and I'm the manager of this group, Sensor Science and Technology at our Material Science and Manufacturing unit, we've seen ourselves all these years to have what we call a noble cause. We put it this way: responding to South Africa's challenges with sensor innovations. That's kind of our raison d'etre. That's what drives us, okay? But in our mission statements, we've always had this one: taking responsibility for the innovation chain and push these things as far through as we can. Never stop at a dotted line and go, I'm sorry, that's enough now. Somebody else has to license it and take it. We've always pushed the boundaries of what's possible and tried to get it out there, and it's been successful as an approach. And I see it happening in a lot of other areas around the company these days, and pilot plants going up and all these manner of things to take the next step along that innovation chasm. What's been nice in this story is the fact that we had a partner in Eskom who were prepared to take a step back down the innovation chasm and assume a bit of risk, and that really has been really key to it. Okay, and just to give you an indication of how intentional we are about innovation, we have this system which is now on the entire Sishen Saldana line, which is a world's first product, using ultrasound, pinging up and down railway lines to pick up breaks in railway lines to stop heavy freight train derailments. Everyone you avoid saves the economy 50 to 100 million rand. So typically would save $500 million plus a year to the economy just by having a system like that. So again, there's some really cutting edge science that we're publishing on the guided wave ultrasound, but we've taken it through to the technology and the product, and this will be commercialized next year. We've got a medical system taking Doppler ultrasound from the specialist at the secondary and tertiary levels down to the primary level. This is part of a study at the moment. We're in Mamelodi at the Stanzibupapi clinic. We're about to expand to a second clinic next month. But this is actually reducing perinatal mortality rates, reducing referral rates, and improving the quality of healthcare. And there are submarines and surface vessels in our own Navy as well as foreign navies floating around with technology that's been developed by the group. So very much a group who's keen to get their R&D out there into the applications. And that's really how we drive ourselves. In terms of the ingredients that make it happen, I said most of these are kind of soft factors, but if these are not in place, then you're not going anywhere. We had a clearly articulated need right in the beginning, and a real technical challenge to be solved. If you have that, your team gets on board. This is actually worth doing. They're not going to do something that's not worth doing. We had champions at Eskom, a number of people over the years who played a role. The names are up there, and they're almost in order, I think, with Nashal, who's actually here with us today, who really waved the flag. They believed in it enough and support through on the Eskom side, not because they believe just in the technology, because they believe in the difference it makes in their business. On the CSR side, a number of people were leading the charge internally and making sure it kept going over the year and supporting it. There are more names I could have mentioned there, but those were important people. Eskom had a very open mind in the beginning, that this wasn't just about solving a problem in the lab, but we could create a company one day. This could go commercial, and in doing what we're doing, we also create jobs and exports and so on. And so they had that bigger picture view. There was a belief always that it was worth doing. Resilience to carry the torch. There were many dark moments when we thought this was going nowhere. It might look shiny when it's presented this way and we got there. There were many times along the way where we just didn't know it was going to go another day. But somehow the resilience of the people, the belief that they had, kept it going. There were people who raised funding every year, and there was the funding itself that actually allowed us to go beyond the short term. Quite often it may have taken 14, 15 years to get the innovation out there. We never had funding for more than 2 or 3 years at a time, and we had to keep pushing the boundaries and showing value and getting that income in to allow it to happen. Eventually we had the CSIR's IP licensing and tech transfer skills that came on board, and people there that all played a role in helping us get it out there. It was new for many of us to get something out and transferred into a company. And then hats off to the UViRCO team, Dirk, Ockert, Jaco, Tersch, Alistair, Rocky, who left us at the time, and others who have joined them since, for actually being prepared to go out, be entrepreneurial, and having that spirit and drive to take it outside. Okay, and then just to wind up, UViRCO's vision obviously is to remain in that market leader position. A lot of that will be done by releasing these next generation systems and new systems and just being innovative and staying ahead of the client needs there all the time. We're trying to lead internationally in terms of the science as well, that UV quantification I talked about. There's now an international CGRE working group looking at the international standards, so we form part of the committee there and helping drive that forward. Building increased intelligence into all products, I think that's a no-brainer these days, so that you can use that diagnostic information to your advantage. And then the classics, but you have to do them, reducing manufacturing costs and focusing on quality and customer care. Okay, so as we come to the close of this financial year, CSIR will finally divest its investment, and we'll be selling out to a BEE partner later this year, so completing all those requirements on us. UViRCO then will stand alone as an independent company in this country, and it's nice to have been part of that journey. It really is. Many people contributed along the way, and I'm really here presenting on behalf of quite a team over the years that have put this all together. So it's a privilege for me to have done it. I just want to say thank you to CSIR and ESCOM people for the journey. It has really been quite remarkable to have a partnership that strong that's lasted for that number of years and has produced these kind of results. And then maybe on behalf of everybody here and in South Africa, I just want to wish UViRCO all the best as they forward off into the future. Thank you very much.